Hi everyone, so I will be discussing Leetcode 1642 problem for this building that we can reach. So in this problem we are integer array, given an integer array heights representing the heights of buildings, and we are given some bricks and some ladders. So we can start our journey from building 0 and move to the next building by possibly using bricks or ladders. While moving from building I to building I plus 1, if the current building height is greater than or equal to next building's height, we do not need a ladder or brick. If the current building's height is less than next building's height, then we can either use a ladder or a brick. So, and we want to return the furthest building that we can reach if we use the given ladders and bricks optimally. So in this problem, I will explain it through this example. So in this example, we are given this heights array and 5 bricks and um, one ladder. Now we can, if this current uh, building's height is greater than this building, the next building height, then we don't need to use any brick or ladder. So here we don't need to use any brick or ladder. But in this case, we need to use a brick or ladder because this 2 is less than 7. So, it is given that we in this example, it is in the explanation it is mentioned that we can use 5 bricks. So we would use 5 bricks to move to here. Now when we are here, now if we use 5 bricks, bricks left will be 0. And again 7 is greater than 6, so we don't need this ladder or brick. Now again from 6 to 9, we uh, this 6 is less than 9, so we need either a brick or a ladder. So now um, so bricks left are 0 and we have one ladder left. So we would use this ladder to go from this 6 to 9. Now, now we are at 9, but after that, there again there is a 14 which is greater than 9. But now we have no ladder left and no bricks left, so we cannot go further, which means that we are at 9 and we want to return its index because we could reach till that point only. So um, we would return um, this output as 4, which is this index. Similarly, now now the observation here is that um, we want to use bricks only for only when we require less jumps, and ladders we can use uh, uh, for higher jumps because a ladder could basically cover any number of jumps. So, but for bricks, um, so let's say we are at 3 and we want to go 18. Now, for going from 3 to 18, we require 15 bricks, but we have only 10 bricks. But also, if we use ladder here from 3 to 18, we can use single ladder only to reach there. So, a ladder would be an optimal um, way from this going from this 3 to 18. Now what we could do basically, we could have this thing. So from 4 to 12, there we need to cover 8. For now 12 to 2 we don't need to use any brick or ladder, but from 2 to 7 again we need to jump uh, by 5, and again we don't need to jump, but here we need to jump by 15, and again here we need to jump by 2, again we don't need to jump, but here we need to jump by 16. Now this is what we have. Now from this, if we see, so basically if we use 8 and 15 for ladder, we would be left with 0 ladder, and bricks would be 10. So what we could do, we could use 5 bricks plus 2 bricks, which means we would be left with 3 bricks, but we cannot do the jump for this case, because we require 16 bricks, but we are left with only 3 bricks. And also if we use any other combination, let's say 15 bricks and 5 bricks. Now, sorry, 15 and 5 for ladder, and for this 8 and 2, we would use bricks. So we would be left with 0 bricks and 0 ladder. And and similarly, if we try to use bricks for ladders for these two cases, then this 30, we would require 15 bricks, which is not possible. So which means that we cannot even reach till this point. We cannot reach till this point, so we can basically return till this index, because we can reach uh, uh, on top of this building. So now basically in the code, what I am doing is that I am using a priority key. So whenever um, we have this, so let's say whenever this difference is greater than 0, which means that uh, basically which means that this heights of I plus 1 is greater than heights of I, we would calculate this difference. Then basically we would check if this priority queue is the length of this priority queue is less than ladders or not. If it is less than ladders, we would simply add this difference. So difference would be added, and we would have this ladder jump sum, uh, where basically we are adding this difference also. And if the priority queue size is equal to the number of ladders, in that case, basically um, there are two things. If the priority queue is empty, which means that this initially, from the initial only we were given 0 ladders. So in that case, we have to add this difference to this brick jumps. And if brick jumps becomes greater than bricks, which means we cannot further go further. So in that case, we would basically store this I as answer, and basically stop the while loop. And um, in the else condition, which means that PQ is not empty, in that case, um, if this priority queue dot peak, which means that the smallest element in the priority queue is less than this difference. If that is the case, then we would want to poll this priority queue, because as discussed, we want maximum sum for ladders, and all the left out sums for bricks, because we need an optimal solution. So when basically after that, after polling this minimum element from priority queue, I would add this greater difference to the priority queue, and also in that case, ladder jumps would have this fold subtracted and diff added to it, and also this fold would be added to brick jumps because um, we are basically now removing the previous um, difference from this PQ, and we want to basically add it to brick jumps because we are given two options only. Either we want to jump using ladders or bricks. So if we are removing a jump from ladder, we would want to add it to bricks. And if brick jumps become greater than bricks, in that case we want to simply stop. Hmm. Now if um, and also the other condition is that if this peak is greater than equal to basically greater than equal to difference, which means that peak already has a greater or equal value present at the top of the priority queue. In that case, we would want to add this difference to brick jumps because as discussed, we only want maximum values for ladders, and other values would basically be accommodated through this brick jumps. Now I would try run this code for um, this second example. So initially PQ is empty. So initially priority queue is empty, and um, I is 0, and we are looping till heights dot length minus 1, and stop is false, and brick jumps and ladder jumps both are 0. Now, so for the first case, we would for I is equals to 0, we would calculate the difference. So difference there is also variable difference. Now difference is this this difference, which is 12 minus 4, which is 8. Now for 8 difference, we would check if PQ dot size is less than ladders, which is true because ladders given us 2 and currently PQ size is 0. So we would add this difference to this PQ. Now again, um, I would increment it to 1. So we would check this, and we don't need to do anything in that case because this height of I is greater than this height of I plus 1. But again, for I is equals to 2, this difference is 5. Now when difference is 5, and we would check if this PQ dot size is less than PQ dot size is less than ladder. So currently it is less than ladder, so we would add 5. Now 5 would be added to the first location and 8 would be shifted because that's how PQS works. So this would be the case. Now for the third index, 7 minus 3, which is 4. So we don't need to do anything. Now again 3 minus 18. Basically 18 minus 3 here. So for index 4, we have 18 minus 3, which is 15. Now we have difference of 15. Now ladder dot size is um, equal to this PQ dot size. So, and also this is not true because PQ is not empty. So we would go in this else statement and check if PQ dot peak is less than difference. And also ladder jumps is 13 because it denotes the sum of these variables. Now this is less than, this 5 is less than the current difference which is 15. So we would add 15 here and 15 would be added to the back of it. And now um, ladder jumps, this 5 would be decremented from ladder jumps and 15 would be added, so it would be 23. And this 5 would be added to brick jumps and um, so, and we would check if brick jumps is greater than brick. So if 5 is greater than 10, which is false, so we would again increment I to 5. We would increment I to 5, and now again for this index also difference is 2. So we would check if this 2 is greater than 8, which is false. So in that case we would simply, basically first of all we would check if PQ dot size is equal to ladders, which is true. Ladders is 2 and PQ dot size is 2. So we would go in this else statement, and in this else statement peak is less than difference because peak is greater than difference because peak is 8 and difference is 2. So we would go in this else statement and add 2 here. So it becomes 7. And now again we check if 7 is greater than 10, which is false. So um, we would basically increment I to 6. So I is 6 now. Now this is 6. Now for this case we don't need to do anything because 20 is greater than 3. Now we would move to here. Now I becomes 7 and 3 is less than 19, which means that difference would be 16. Now difference is 16, and here we would see, now we would come in this if statement, and because 16 is greater than 8, we would add 16 to PQ and add and decrement 16 from 8, which means that, or decrement 8 from 8, which means that it would be 15 and then add 16, which is 13, and add 8 to brick jumps. Now brick jumps become 15. Now 15 here is greater than 10. The allowed bricks only, the bricks are allowed, the number of bricks allowed are 10 only, and we are saying that we want to use 15 bricks, which means that we have to stop here. So we would stop, basically do this, basically make this stop as true, and the answer variable we would set it to 7, and finally come out of loop and return this answer. So this is the explanation, uh, solution of this problem. Thank you.